this is an eye too. It's a modern eye on the sky, one of the radio telescopes at Westerbork in northeast Holland. And it's typical of the sophisticated equipment that astronomers use to explore the universe today. Hello, I'm Heather Cooper, and soon you'll be seeing my new TV series, The Stars. The Stars boldly goes where none of our space probes have yet been, away from our backyard and into the realms of our star city, the galaxy. In the 6 programmes, we'll be looking at how stars are born, how they live, and how they die. But first things first, how do you tell which star is which? Ben, this is a really great place to do astronomy.
It's the only way to do astronomy.
It's certainly very, very warm. What's up there tonight?
You can see constellation of Taurus.
Uh-huh.
From there to about there, this whole triangle there is the head of Taurus, with Aldebaran, the brightest star, smack dab in the middle there.
Yeah.
And on the right, on the top, you can see the 7 sisters, also known, as you well know, as the Pleiades.
But in the middle of Taurus and Gemini is my favourite constellation just there, Orion the Hunter.
The 3 stars are right up there.
Yeah.
Fantastic.
A clip from programme 1. Well, we have moved on a bit since those days when we saw the stars as being part of a giant dot-to-dot puzzle. But at least learning the constellation patterns helps you find your way around the sky. Nowadays, we know that each star is a hot, brilliant sun in its own right, but very much further away. In fact, as I explain in programme 2, we've managed to learn so much about individual stars that it's almost embarrassing. Take the star catalogue, for instance. It contains the vital statistics of something like 45,000 stars. Things like their temperature, their brightness, even what they're made of. So how can astronomers know so much about things which are just little specks up in the sky? They can't put a star in a laboratory and do experiments on it. In fact, you have to take just what's on offer, and that's starlight. And, like detectives, seek out the secret codes and messages that are hidden inside. A real tricks of the trade programme this, which explains how astronomers have managed to wring so much information out of points of light millions of kilometres away. Programme 3 looks in depth at our local star, the Sun. And we discover it's only really recently we've learned what makes the Sun tick. Last century, astronomers succeeded in taking the Sun's temperature for the first time, and they worked out it was 6,000 degrees Celsius. They hazarded a few guesses as to what its power source could be. Coal was suggested because at that time it was the most powerful natural fuel known to man. But they soon realized that even if the whole Sun was made of coal, it would burn itself out in just 6,000 years. The next suggestion was that the Sun is powered by a continuous rain of meteorites bombarding its surface. But again, there just aren't enough meteorites around. And then they all hit on the idea that the Sun is actually shrinking. The effect of compression might keep it hot for millions of years. But you need have no fear that the Sun is going to shrivel up. It is fueled instead by a far more impressive power. The power of the atom. But where did the Sun, and the other stars for that matter, actually come from? In programme 4, we go to a rather exotic location to find out. This incredible pool of molten rock is on the flanks of the active volcano Kilauea on the island of Hawaii. It's only when you're standing close to a seething, teeming lava lake like this that you're forcibly reminded, 5 billion years after the Earth was born, parts of it are still hot and active. Truly, our planet was born of fire. It's almost impossible to conceive the forces that must have been around to make it come into being. And yet our Earth, and you and me, and all the teeming life it now supports, are just byproducts of a much more tremendous act of creation. The birth of our local star, the Sun. Our Sun was born so long ago we might never know how it happened. But other stars are being born now. And astronomers are studying these new stars, not just to answer the questions as to how and why stars come into being, but why there's all this activity, and why, in the end, there's life itself. And you thought Hawaii was all grass skirts. Actually, it's the home of a major observatory, which is perched 4,000 metres up a high mountain. And this observatory is dedicated to unravelling the mysteries of star birth. So, no, we didn't get to spend all our time on the beach. If stars are born, then it follows that they must die. But their lives are so long, and ours are so short, that it's only very rarely we actually catch one in the act of dying. But in early 1987, one star obliged, spectacularly. The Large Magellanic Cloud, 170,000 light-years away and the nearest galaxy to our own. It contains 10 billion stars. February 23rd, 1987, a tank of water a mile underground in Ohio. A stream of high-energy particles, which has taken 170,000 years to reach Earth, zips through the tank and the Earth in a fraction of a second. At the time, no one notices. The following night in New Zealand, Albert Jones, an amateur astronomer, is observing the Large Magellanic Cloud. He can scarcely believe his eyes, because in the middle of the familiar galaxy is a bright new point of light. He thinks it must be a supernova, the explosive death of a giant star. But no such event has been visible with the naked eye for the past 400 years. His first priority is to alert other astronomers.
And I've been looking at the Magellanic Cloud, and I've been looking...
That was from the beginning of Programme 5, which also goes into how our sun is likely to die. And Programme 6 explores life after death, the bizarre behaviour of star corpses. But let's not end on a morbid note. As I said at the beginning of this programme, not even our space probes have gone to the stars. Will they? Anthropologist Ben Finney.
We're going into space, we as a species, that is, sometime, and we'll settle on planets within the solar system, and I think eventually we'll go interstellar and settle around other stars. All those places we think are uninhabited. Now, the same case with the Polynesians. Their ancestors rather, set out from Southeast Asia, started working their way into the Pacific. The first islands they came to were already inhabited, but soon every island they came to was uninhabited. And they kept pushing and pushing because they were the only people in that part of the world. Every island, therefore, was new and virgin, open to them. I think we have the same prospect open to us in our solar system and probably in other stellar systems. We're the animal that expands by developing technology, go where we shouldn't biologically be.
Well, that's certainly something to look forward to in the very far future. Meanwhile, what you have to look forward to is my new television series called The Stars. It's got a book accompanying it, and as you can see, it's been translated into Dutch. That's all from me for the moment, but I'll be seeing you on TELEAC very soon. Bye for now.